The first question you should be having in your mind, and that is, what is Terraform? Okay, what is Terraform? So typically, we all say, hey, this tool basically using this tool, you can do coding for infra. Okay, coding for infra, code for infra. So see, we've been discussing so much about, yeah, coding for the product, coding for the testing the product, but nowadays this keyword is coming into a picture, coding for infra. What exactly here I'm trying to talk about? So first of all, you have to understand, very simple question is like, in order to run any software, okay, in the production I'm talking about, okay, just for the sake of discussion, in the production, how many tools you have in your organizations? How many tools? How many tools you are using for it? So if you want to visualize that, probably a lot of tools are there. Some of this I must show you some visualizations here. Terraform providers, I just type it, and pretty much huge list of tools you guys are using. So look at this here. You are using this cloud platform like AWS, Azure, Google Cloud, Kubernetes, Alibaba. You are using Consul. You are using DNS servers. You are using, Docker, Kubernetes, MySQL, and you are using a lot of tools actually. A lot of tools. See, you are using public cloud. You are using asset management software. You are using cloud automation software. You are using communication and messaging software. You are using container and orchestration software. You are using CI/CD tools. You are using data management software. You are using databases. You are using the logging and monitoring. You are using some of the infrastructure management tools. You are using network services, networking tools. You are using multiple different platforms. You are using multiple tools for security authentications, VCS, web services, app services, and so many tools you are using. So you have so many tools in infra, simple. You have so many tools in infra. So nowadays we have a jargon that is called, hey, write a code for everything. Yes, everything means literally everything. Okay, everything. You write a code for the product. Okay, write for the code for the testing of product. Okay, write a code for the all CI/CD automation, all deployment, all the security also you write a code for it. Okay, operations work also write a code for it. Infrastructure also you write a code for it. So basically nowadays we have a practice and in which we do practice coding for everything. Okay, so yes, now you can understand that where the Terraform is coming from. So you have an infrastructure, you want to do the coding for infrastructure, and for that you need certain tools for it. Okay, you have so many tools which just now I have shown you, so many tools which you want to use it. You need to use it to run your applications in the production. So for that you need to code for it, and for that we need a Terraform. So at a high level, did you understand that Terraform? Why do we need, all of you? All of you?
That's correct.
Yes.
Yeah. So now let's understand a little bit in the right
Hello?
perspective. Yeah, I can
Hello?
hear you. Yeah, I can hear you.
Yeah, is it okay to assume that all software are regarded as tools or applications as tools?
Yes, Abel, I'm so sorry, I'm not able to hear you very clearly. But if you can type the questions, probably it'll be easy for me.
Okay, I will do that.
Yeah, yeah. Okay, so yeah, so let's understand that what kind of pain area you have it, and why do you want to write a coding for infrastructure. So yeah, there could be hundreds of use cases we can have it, but I'm going to help you to visualize just one simple use cases. So why infrastructure as a code matters? A simple story, short story. So here, let's say you are starting a new project. You want to use Ruby. Why? Because you know Ruby. or maybe you can use Python also, Java also, no problem, anything. And you install something, let's say Ruby, you want to install it for that particular project. You got some issues. You got some issues. You did Google, Stack Overflow. Okay. So you success and you got it. Again, you install some other tools to make your application up and running. So again, you got an error. Now, again, you visited Stack Overflow and somehow it fixed it. Okay. After this, again, you want to install something else. Some code changes have happened, some library changes happen, and again, you want to do some changes in your infrastructure, in your machine servers. So you get irritated. Okay. You started thinking about, yeah, things are not getting installed very the way I want it. But still you solved it out. You spend 2 hours of time, okay? 2 hours of time, random, some here, Googling, there, some, and you somehow you figure it out and then you install it. Success. Wonderful. Now you're happy. So this is how you do that every time. Remember, you are doing a development, you are doing the bug fixing. For that, you have to have a set up a dev environment. You need to set up a QA environment, and you know that how much time you spend for setting up the dev environment, QA environment. 2 hours, 3 hours, 4 hours. Every time you have an error, you fix it. All this thing you do manually. All this thing you do manually. Okay, but this kind of error, which will definitely irritate you over the period of time. Okay, and eventually you will get it working, and that is how this has been done from last so many years. You have to integrate this tool, there are some errors, fix it. You have to install that tools, there are some errors, fix it, and you will eventually get it working. That's how it is. But now what you have to do, you have to deploy your code in the production. So again, now development environment was different, QA environment was different, production environment is different. Probably you have to learn so many different tools, AWS, different services you have to learn. You have to learn with EC2, you have to learn with storage, you have to learn with this. Now the environment is different, so again you are getting different kind of errors. So basically you get irritated with this kind of stuff, but still you are working, and eventually you would get it working. So what are you going to do? On top of that, there are so much of security issues which is keep popping up, and you have to update your operating systems also. Okay, and update your applications also, update your web servers also. And this kind of issues, you keep doing it and keep getting frustrated, but you keep working it. So you started thinking the problem is Rails or Java or Python or so many tools, so many infrastructure which we're using the tools for this application. No, that's not a problem. The problem is you are configuring servers manually, and that's a problem. You have to automate it. You have to code for it. So that is where, if you start coding for everything, if you start coding for infrastructure, the same code will work for the dev, same code will work for the QA and production, then all the issues will get disappeared in no time. So yes, just a one use cases just to help you to visualize why coding as an infrastructure is needed. Are you understanding this? All of you?
Yes.
Yeah.
I do.
Now the question is, see, you have to become architect today. I'm not going to teach you what is a Terraform. Rather than you're going to come up with some solutions, what is a Terraform. So let's take it in a different approach altogether. There's one project we all will develop today. See here, this is the AWS, this is the Azure, or let's say Google Cloud. This is the Jenkins, this is the Kubernetes, and this is the database of database. Okay, so now, and let's say this is the database, or let's say GitHub. This is the GitHub. Okay, so now you need to automate AWS. Okay, if you want to automate AWS alone, if you want to code for AWS, which service we use? Anyone remember that? Anyone remember that?
Cloud
Cloud
formation.
formations.
Cloud formation. Now, if you want to automate, let's say Azure, anyone remember that which services we have to use? You have to update. Means when I say automate means code. Okay, simple coding for AWS cloud formation, coding for Azure ARM. Okay, coding for Jenkins file, coding for Kubernetes, let's say Helm package or deployment package like that. Coding for GitHub, maybe some shell scripting or something like that. Now you see that here, this cloud formations is in YAML, Jenkins file is in Ruby, Kubernetes Helm also is a declarative languages. Here, what is this? GitHub, shell scripting and stuff like that. So think about it. Don't you get crazy? See, you have hundreds of tools, and to automate every tools, you need to learn different scripting language. Someone has to run JSON, someone has to learn YAML, someone has to learn some Jenkins file like a Groovy, someone has to run XML, Maven and this one. What is and someone has to learn self scripting, someone has to run PowerShell scripting, someone has to learn Python. So basically, to code for infrastructure, that's okay, that's a nice idea. But if you start implementing it, you have to do the coding for everything, and you have to learn everything, and you get crazy about it. Don't you feel frustration? All of you? All of
Yep.
you?
At
So how do
times,
we
yeah.
solve it? So how do you solve it? See, you need to do the code for infrastructures. You cannot run away from that. But how do we solve it? Hey, can we have only one script? Think about it. Can we write this? Me, this is a human, this is us engineer, and I need to write only one script. Only one script. I need to learn only one script, and this script should be running on AWS also, Google Cloud also, Jenkins also, Kubernetes also, GitHub also, and all the tools which I said here, it should understand and should automate for everything. I repeat, it's for everything. Can we have this kind of magic? So actually, there's no as such tool available. So can we design it? Can we design it? So let's say I am a developer, and my organization say, hey, you need to design some tool which where that people will write a programming language in only one language, and this language will be transformed to AWS supported language, Google Cloud supported language, Jenkins supported language, Kubernetes supported language, GitHub supported language, all these things automatically. So how do you design this product? So being an engineer, what I will do, I will understand the architecture of these tools. So nowadays, if you look at this, all this tool is supported with the API. Don't you think so? CloudFormation works with API. ARM works with the API. Jenkins file also you can get it works with the API. Kubernetes again you have API server itself. GitHub also you can work with the API. Don't you think so? All of you? Hello? All of
Yes.
you?
Yes.
So all these tools that you have here, most of this is web service tool. You look at this here. These all are web service tools. All support API. AWS support API, Azure support API, Google Cloud support API, Kubernetes support API. All these tools which you can see here, which you are using in the infrastructure, are based on and supporting with API. So what we do? So I am as an engineer, what I will do? I will try to convert this script, which is a script which is written by you and me, user, for coding for infra, and convert into API supported for AWS. This code again, let's say this is divided into 4 parts. 1, 2, 3, 4. So this is the AWS code, this is the Google Cloud code, this is the Azure code, and this is the Kubernetes code. So this code, AWS code, will come to AWS APIs, convert into that. This code will be converted to this API, and this conversion will be happening to this API supported one, and will be happening this one. So now what do we need here? So basically we need one sort of convergence tool actually. So here in between we need a conversion tool. So this program will be converted to API supported code. I need this tool, I need this one tool also, I need one tool. That means I need see, the engineers can write only one programming language, and then I need to convert this programming language to the supported platform supported language and send it to the API, and API will do the stuff and get me the outputs. What about this idea? Is it work? Is it good or not good? So that way, you know what? Don't need to learn too many programming language. You need to learn only one language. Correct? And still you can automate for everything. What do you think?
Yeah.
What do you think?
That is good.
It's a good idea, right? So this is a good architecture. You know what? This is nothing but Terraform architecture. So what is happening? Look at my screen, guys, very carefully. You, as an engineer now, write a code, but you write only one code. What code? This called .tf. .tf means Terraform program. It's like a Java, we write in .java. Terraform, we write a program in .tf, and that's very simple. That's very easy to use it. Don't get scared with that programming. Very easy to write a program. Okay, I'll teach you this one. So here you write a program, TF program. You know what? This TF program, you send it to, there is one executable, and that is called Terraform executable. So I must draw this. This is the Terraform executable. I should be having bigger one, right? So this is a T. This is executable. This is a Terraform actually. So all the program is being sent to Terraform. And this Terraform, what they do, Terraform read this program, .tf program, and send for conversion. And what we call it, you know, this, what do we call it? Anyone have idea? What do we call it?
Assembler.
Providers. Will you remember this? All of you?
Yes, provider.
What we, yes, you call it providers. So this conversion script, what we have, basically it's a tool actually. So that means if you want to code for 100 tools, you need 100 provided. Very simple thing. You need a Terraform anyways. You need to write a Terraform program anyways, but you need a providers also. What their work is to convert your program, human programs, to the API supported program for that platform. So this provider send this code to this AWS code to AWS, and Azure code to Azure, and Kubernetes code to the Kubernetes. And this is supported by APIs, call API. And then let's say you said, hey, give me one VMs on AWS, give me one VM on Azure. Let's create one resources on Kubernetes, or let's say this. Let's create one repository on GitHub. So all this thing code you have written here, and this code is sent to the Terraform executable. Terraform executable has sent to the provider executable. Provider executable has sent to the each APIs, and each API will send that request to the platform, and platform will do the work based on the authentication provided. And after that, you know what will happen? This response will be stored. Please mind it here. This response will be stored in the one file called, okay, one file called state file. Will you remember this terminology? All of you?
Yes.
State file, see, API
Yes.
response, whenever you get it, you have to get it in a JSON format. So what happens? Anytime, just forget about the Terraform. You make a request to the APIs, you will get in a return value in a JSON format. It's a supported format nowadays. Okay, so here, this provider has requested API with certain request. AWS has responded saying that, okay, let me create or let me not create, whatever it is, I don't care. And they created it and stored that JSON output in a state file. So it's very simple, guys. See here, the flow is very simple. You want to write a coding for infrastructure. This is you. You have to write a TF program. How to write? Don't worry, I'll teach you. This TF program, you have to run it against the Terraform executable. How to install Terraform? I'll teach you. Don't worry about it. This Terraform will send that code to the provider, different providers. This provider will send to the API request, known API request, API call, and API will send this response in the state file. Okay, and then you will get to know what has been done. So now let's say you want to think about it. Simple. So you want to create, let's say, 10 VMs. So you
Rajesh, one
write,
quick question here. So
yeah.
again, we are basically talking about cloud here, maybe cloud providers. So do we have VMware providers also, where maybe we can deploy the infrastructure
Yes,
in our own premises?
yes. We have Terraform. See, VMware also support API, right? See here,
Okay,
vSphere. Here you have.
all right. Okay, thanks.
Yeah. So here, simple thing. I say, hey, I want to create 10 VMs on AWS. You wrote in the tier program and you say apply. Apply is a command, okay? Apply is a command. You send to the Terraform saying that, hey, Terraform, create this 10 VMs of my desire. This is my desire. Terraform send that request to the provider, to the API. AWS responds saying that, oh, I've created this 10 VMs. This is the information state file, and work is done. Now you say, hey, Terraform, I want to delete that 10 resources. So what you will do? So for deleting, understand that for deleting, what to delete, it has to be there. It's not like everything you on AWS you want to delete. Whatever you created, it should be deleting. Correct? Correct? So the question to you is, where do we have that knowledge? Where do we have that knowledge here? Which are the resources have been created? Tell me, all of you. Where do we have knowledge?
On the
In this,
AWS.
No. The knowledge whichever the resources you created is in response of state file, right? Correct? Stored in the state file. Whatever you created, see, you send a 10 request. AWS return saying that, okay, these are the resources I created for you. So it's there in state file. Okay. So state file, you have all this information. So you want to say next time, hey, Terraform, delete the resources. So Terraform will read this time, not your this one, but they will read this one also and state file also. They will match, okay, this is the resources which you want to delete, whether it's created or not. First, let me check. And then it will send, hey, delete this 10 VM, and delete has happened. So apply, delete, apply, delete. You have to keep working on it. Are you understanding the flow?
Yes.
yes.
So it's very simple flow. So guys, this is you. You will do what? You will write a Terraform program, send it to Terraform. Terraform will send to the provider. Providers will send that to API of the infrastructure. Response will be sent from API to state file. And this is the overall workflow you have to work with. So if you do Terraform plan, it's a dry run. Check Terraform apply, create an infrastructure. Terraform destroy the things which you have created. Are you understanding? So what you need to do? First install the Terraform, then install the provider, then write out what you want in the infrastructure, and run this command. That's all.
So you mean Terraform, it is used to automate our work. So instead of creating the EC2 machine manually, right? So on the time we give that command to the Terraform, right? And Terraform will do that work, right?
That's correct. Yes.
Okay. And what about the code? So developer write the code, right? And they also want to deploy that code on that EC2 machine, right? So is it
Yes.
also through this Terraform?
Okay. So understand this. Yes, that's a very great question. I wanted to ignore for some time, but that's okay. See here. Tell me one thing. If that is the work of AWS, here provider is, let's say, AWS. So what code has to be installed in let's say EC2 instance? Who's going to work on it? Tell me.
Yeah, developers obviously.
No. I'm saying the automation of this. Talk in terms of automation. Which tool you can use for deploy your software in operating system?
So we use actually
Ansible,
ANSYS. Yeah,
Chef, Puppet.
yeah, Puppet.
Correct, now? Yeah.
Yes.
So yes, what you have to do? See, think logic. AWS can give you the VMs. Agree with me?
Yes, I do
Yeah.
have a question though.
Just a second. Just give me 1 second.
Okay.
AWS will give you the AWS instance. After that, in AWS instance, what you need to do, run some script that can be shell script, PowerShell script, Ansible script, Puppet, and Chef. And those scripts will do the required configurations. So the question is, how do we call that script? So see here, when you call, let's say, I'll call about the resource specification. Just give me some time. I'll come back to that. I don't want to jump the gun. But for your answer, this can be done by provisioner. Okay. So I'll talk about it. What is the second question?
Yeah, so my question was just based on clarification because it's my understanding that Terraform can actually be used for deploying, and then Ansible and Chef for configuration management tools also can be used for deploying.
I would say, there's so much of confusion around it. My learnings is very simple.
Can you
I
repeat
think
that?
we lost Rajesh. Is it just
No,
me
okay.
or
Yeah, so I've
Rajesh? Can
actually
you
used
hear
that.
us?
It seems he may have been disconnected.
Rajesh, can you hear us? No.
It seems that he may have been he's offline or something.
Yeah, but he's able to control his laptop. So probably some other issue. I think we can chat him. We can chat with him.
Can someone do
Yes.
so?
Can you hear me, all of you?
Yeah,
Yes,
Rajesh,
now
we
we
can hear
can.
you now.
Yeah.
Yes,
Sorry.
it's okay now.
Yeah, I think I lost the internet. I guess it's okay. So now, yeah. So I was discussing something about where should we use Terraform and where we should the configuration management tool. So let's say if you want to create infrastructure, for example, at a cloud level, or API level primarily. So you can use the Terraform for it. Now let's say if you want to configure the resources means a virtual machines. The inside, see, virtual machines can be configured using should be configured using Ansible or Chef or Puppet. By the way, with saying that, see, Chef, Puppet, and Ansible is the best solution for managing the resources, servers. But in Terraform also we have a provisioners. which you can use that to do that stuff. So yes, it's available. So for example,
Hello everyone, if you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc. Kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.
Thanks for watching. Want to study further? Join our training programs today.